Okay, hello, can you hear me well? So I'm not new, right? Okay, so I feel like Britney Spears with this mic. Okay, yeah, so this is my talk, continuous testing, and we are going to try to improve or just going a step forward in our CI/CD pipelines. I'm Fran Guerrero, as my colleague said, and we are going to talk a little bit about DevOps and testing, okay? First of all, some vocabulary. Okay, so we are in the Saborio Hall. So I think people from Malaga, this is quite easy, but for people outside, so a Saborio is a rude person, okay? It's a person that is not kind. Perita is like a little peer, okay? Is when something or someone is cool. Chorraera, this is a nice one. It's a children's slide. And the best one is Guarrito. Okay, Guarrito is a drill, and we call it Guarrito because the brand is Warrington, and in Malaga we say Guarrito. There are much more, okay, but for today it's enough. Okay, so talking about Malagueño, so I need to apologize in advance for my Malagueño accent in my English, but I hope you understand me. So in case you don't understand anything, just raise your hand and I can repeat it. Okay, so I'm glad to meet you here. Some new faces, some old friends, colleagues. So that's very good for me. This is my eco slide. So I'm Fran Guerrero, you know. I'm working as a QA manager at Pilitics. Talking just 20 seconds about Pilitics. Pilitics is developing a PIM platform, a Product Information Management System. So it's a platform where we centralize all the information for products that are later on synchronized with different shops like Shopify, eBay, Amazon. So we only have to manage all the information in our platform, not in every shop you have. Okay, so in case you are interested in e-commerce or you know someone interested, just talk about Pilitics. It's a very good solution. I'm also working as a training consultant in Relevant and Socrates. They are development academies, something like that. And a speaker at conferences like forum test related, basically. And Jay on the beach now. Father of two kids, freaky of video games also, and lover of whiskey. Okay. And you are maybe you are questioning how do you do that? Energy drinks. Okay. Okay, here you are my contact details. I will repeat them at the end of the presentation, but just in case you want to contact me, LinkedIn or Twitter or email. Okay? Okay, so topics we are going to treat today. But let's start with Agile and DevOps, just a quick review, because they are the first steps before moving forward to CI, CD, and DevOps. We are going to review also CI and CD pipelines, the main information about them. And let's start talking about continuous testing. We need to talk, obviously, about automation, test automation. And we'll try to see some small pipelines at the end of the presentation related to testing stuff. Okay, so can you figure out what are we talking about with this picture? No? Okay, no, we're not talking about COVID, okay? So we have three waves here, first wave, second wave, and third wave, but we're not talking about COVID. First wave, Agile. So Agile was an improvement in software development. So we were working in waterfall, traditional methodologies, and Agile is nothing new. It was invented 20 years ago. So Agile is a mindset, it's understanding, collaborating, learning, and staying flexible to adapt to the functionality that the clients want, or just incrementing our product, always giving value to the customers. Okay, I think most of you know Agile, so it's just a quick review. So we have some kind of methodologies like Scrum, Kanban. The main thing that they are improving against the traditional methodologies, it is the fact that we are developing and delivering faster than before. So instead of delivering in 6 months, we can go to production or releasing every 2 months. Every 2 weeks, every two weeks, or every 3 weeks. Okay. Main concept from Agile, because this is the beginning of the continuous testing. Whole team approach. So we are not working as departments. We are working as a single team. We are all integrated: product, development, and testing. This is called the Three Amigos. So product is always drinking. We are defining our requirements in a collaborative way. We are managing all our tasks, visual management, BOAS, Jira, and so on. Quality is responsible from now on, is responsible of the whole thing, not only QA. We can define also definition of done, and we can do Agile testing. So the roles, to be honest, in Agile are overlapped. So they are not single departments. So we are working together, and some tasks we are overlapping each other. With Agile, we start talking about early and frequent feedback. Okay, so we move to the left in the software development lifecycle. We are testing early. We are doing some risk-based testing. We are doing exploratory testing. We are following the automation pyramid, something like that. We are repeating this process. So we are now working in an iterative and incremental way, and we are repeating this sprint by sprint. Okay, so this is a very good improvement compared with the past. Second wave in software development, DevOps. DevOps is one more step. DevOps is not a person. Okay, I know the role is called DevOps, but it's not a person. It's a culture that promotes collaboration between development and also operation. So we are including now operation team in the equation, in the formula. We are creating software application with high quality and faster than ever with DevOps. We don't have this wall. This is the wall of confusion between operation and development team. So with DevOps, we remove this wall, and we can work together, identifying bottlenecks, improving feedback, sharing the responsibility, and delivering high-quality systems. Main things from DevOps: continuous integration and continuous deployment. Okay, so we are going to talk a little bit about this. So you have this kind of workflow or pipeline. So we are doing this step. We are going to see. This is going to be repeated in an infinite loop. Okay, from merging our code until deployment, we are going to repeat this in this infinite loop. But there is one problem in this loop. It is not easy like that, because this is only having one environment. But the reality is that we have several environments, like, for example, testing, staging, whatever. So probably the pipeline is a bit more complex, something like that. So, and you have so many tools to implement this kind of pipeline. So this is based on Agile, but it's giving much more value, and it is much more complex. Okay, so there is still a problem in the DevOps infinite loop. It is the testing. Testing is still considered as a phase in this loop, and we need to move forward. We cannot think that testing is only a small phase in all this pipeline or this workflow. Okay, let's talk a bit about this concept, because it is important to understand first this until we can understand continuous testing. So continuous integration basically is merging your code, small chains, and run some kind of test for these chains. For example, unit tests, something like that. And what is continuous delivery? It is once you have passed your continuous integration, then you can release your small changes to an environment and run more tests, run another kind of test, okay? So this is the CI/CD process, basically. I think you should be familiar with it. Okay, there is one more step that is continuous deployment, but continuous deployment is when you want to deploy automatically to production, okay? So DevOps is more related to continuous integration and continuous delivery. It is important to distinguish them because CI/CD sometimes CD is confused between continuous delivery and continuous deployment. Okay, so let's talk about the pipeline, okay? So how we implement all these things, not in theory, but in reality. So we have the continuous integration, we have continuous delivery, and we can have continuous deployment. So this is an example of a pipeline, okay? So this is an example. I don't know if you understand, maybe some of you, DevOps professional, for sure they understand, but maybe QAs or maybe some developers, they don't understand what is going there. Okay, so it's not so difficult. So it can seem difficult, but it is not. Okay, let's try with this picture. It is an easy one. So let's start from our source code. Okay, we are coding, we are developers, so it's normal, we have code. And this code is introduced in the version control. In that moment, this pipeline is triggered. So, I mean, it is starting all this process in the moment that the code enter into the version control. So it is quite important to have a version control. There are still some companies that are using zip files to share the code between their developers. So please don't do that. Just use version control. What is doing the pipeline at the beginning? So building our application with a building tool. It is building the application. And after building the application, it is running some tests. Unit tests or integration at the component level tests. And when these tests are passed, it is packaging and creating the artifact. It is our application. Okay, this is stored in a repository, could be S3 or Amazon or whatever, Nexus, whatever repository. Later on, we already have our artifact. We can deploy this artifact, this application, into our environment. Previously, we deployed in a pre-production environment, staging or whatever, integration environment. And we run more tests, integration, end-to-end, another kind of tests. And finally, if everything is going good, we can go to production. It's easy to understand that way, okay? This is the typical pipeline. Could be some variations, but okay. Best practices when doing CI/CD. Merging small and merging a lot. Testing culture among developers, not only QA. Good peer review processes, okay, to approve your merge request or pull request. Automation, you need integration, security, performance. We're going to talk about that. Releasing small batches, small changes. This is coming from Agile. Culture of testing, and we have nowadays some tools like GitLab CI/CD, GitHub Actions, Azure DevOps. We have too many tools to perform CI/CD in an easy way. It's not only Jenkins, okay? We have several tools, and it is not so difficult. Okay, so if you think on this infographic, you can see the continuous integration part. So it's the part at the top. The code entered into the version control is built, and unit tests are run and passed, and the code is packaged, so you have your artifact. This is continuous integration, and you have to do that in every small chain, even in every commit, okay? After that, the artifact is caught and deployed to an environment, and more tests and run, okay? This is continuous delivery. And finally, if we have the final step also automated, we were talking about continuous deployment. Okay, so we have these waves: Agile, DevOps, and now we are right at that point in the third wave. And the third wave is continuous testing. Okay, so let's remove the testing part. Let's remove from this infinite loop the testing part. Let's remove it from there. It's something like that. So what happened with the test? Okay, this is continuous testing. We need to test in every part of this loop, not as a phase at some point. We need to try to include our test in every part of this loop. At the beginning, and in the middle, and at the end. Okay? So these are the important parts. So I'm talking here today about continuous testing because sometimes we understand that a pipeline is only deploying to an environment or building and deploying our application. That's not continuous testing. We need to include the automated tests in our pipeline. We need to include them, and we need to have them at different stages in this pipeline, not only at the end or not only at the beginning. We need to include the tests. So performing a very good pipelines and CI/CD is having automated tests in the pipeline. So we need to talk about test automation. We cannot think about continuous testing without automation, okay? Test automation is about supporting testing with tools. It's not about replacing tester by tools. So it's automation, not automagic. You cannot fire your team. You should have them with you. And let's think about some tips, because when performing test automation, we need to try to cover the different levels of testing, okay? So as I said, the pipeline is not only one kind of test. It is not only testing at the end. It is testing at different levels and at different moments in our pipeline. So we need to cover unit tests, integration tests, system tests, and acceptance tests. We have a lot of frameworks nowadays to cover this level. So there's no excuse. Just pick up the best framework that for you and use it. Okay? So let's see some tips from every level. Okay, friendly reminder. At the top of the pyramid, so automated is much, the cost is higher, okay? The execution is also slow. And at the bottom of the pyramid, you have a test very, very quick and tests that they are easy to maintain. So you should try to keep this proportion, more tests at the bottom and less tests at the top. Okay, so let's talk about the first level, unit testing. Unit testing, it is a good practice for doing continuous testing to use TDD. TDD is test-driven development. That's it, basically following this flow. I think you all know about TDD, or you have heard sometimes. So it is basically writing your unit test before you write the code. You write your unit tests, execute them. They are going to fail, okay, because the code is not writing. And then after you have your unit test, you write the code. The code should accomplish the test that you are writing. So you are ensuring that your tests are passing always when you develop that way. This is also a way to integrate QA more with developers, because QA can think on this unit test in advance, and they can help developers to create this test plan or this test strategy before the code is created. It's a good practice. It's not easy to get, but you can try. Basically, with this, we improve the code coverage. We focus on design and architecture, because it is a good practice also to use mocks to just to try to test some integration at this level. And so that way you are thinking in a small parts, in small pieces, instead of monolithics, okay? Okay, let's talk about the API also, because sometimes we are forgetting about the API. Okay, sometimes developers are doing unit tests, QA is doing Selenium, end-to-end, Cypress, whatever test, and no one is doing API tests. You can use even Postman, so there are a lot of libraries like ResAssure and some other frameworks, but even using Postman, you can integrate your tests in the pipeline. We are going to see later. So just don't forget about API. Use Postman. If it is easy for you, just create your request, your test. Postman has a test tab where you can write your JavaScript test cases, and you can run them in the tool, but you can also run them in the pipeline. We'll see later. Okay, what about end-to-end? We are in a system level, which is more difficult to maintain, and we need to find some ways to get this maintenance cheaper, okay? So one way is using page object model. It's a design pattern. I think most of you should be using it. Basically, is creating some classes which is a page object, and these classes are including some actions that the user is performing over that page, and also the elements that are actioned by the user, okay? This way, we deaccouplate these classes from the test scripts. Okay, so the test scripts are only the test, and the page object is where the methods and the elements are living. Okay. Okay. The last level, acceptance level. Let's talk about user stories. Okay. So how can a user story is the requirement for our application? So how can we convert this user story to automated tests? Okay, so normally user stories are including or should be including acceptance criteria, scenarios, whatever. So there is one way. If you write your user story using scenarios, using Gherkin language, given when then syntax, there is a way to translate this acceptance criteria, this requirement, to automated test cases. So if you can convert your requirements into automated test cases, you can include them as part of your pipeline also. Okay, so this is an end-to-end test, not BDD. This is using page object model. As you can say, you have the page and you call a method from that page and you perform the action. Okay, having this is you can read it, you can understand it, but you as a developer or as a QA, but user stories normally are written by product or business people. So if you try that a business people is writing this, it's going to do that, okay? There's no way, so we need to find a way. The way is BDD, okay? BDD basically is using the behavior of the system to express how the application should work. So it's behavioral driven development, and you use the given when-then approach. It is a way to write your requirements or your automated test cases that everyone understands. So business, developers, QAs, marketing, whoever. This way, we improve the communication because everyone is understanding the same. Also, we reduce the cost of quality control. We can estimate better because we know the exact behavior that the application should have. Better user experience because it's focused on the use of the application at the final stage. And also, we can use it at documentation even. So basically, you can translate the test that you have behind in a test like this. I think everyone is understanding BDD because it's an easy way. Okay, how it's happening? It's not magic. Okay, so basically it's an abstraction layer. We have under every sentence that you can see in the test case, there is a piece of code that it is implementing the action that you want to perform. Okay, so it is not magic. You can write it like this, but behind every sentence there, you should write a script of code implementing that function. But it's another layer, so you can have your production team writing like this, and your developer team doing the backend. Should be a kind of backend. Okay, this is the pyramid of automation. This is the normal test types that everyone is running or should be running, but we have more. We need to think in our automation strategy. With continuous testing, it's not only doing unit, API, or system. It is doing also performance. It is doing also security. It is also doing usability. So we need to think in our application. We need to think in our clients and see if we are facing something related to the business, if we are facing something related to the technology, if it is critical, the technology that we use, because we want more performance or whatever. And we need to think in incorporating more test types in our pipeline. So you can choose the test type from the quadrant that you prefer or it is useful for you. For example, security. We have a lot of different security testing. Normally, people is forgetting about security. It's depending on the application. It's depending on the business. If it's a bank application, you need security, of course. Performance also. If your application is going to be under some pressure, a lot of customers, a lot of requests, whatever, you can use some tools and you can define also test cases in Python or any other language, and you can have your performance test that you can incorporate also in your pipeline. Okay, so in this way, a new role is born. Okay, it's called QA Ops. It's not DevOps, it is QA Ops. Basically, it's QA understanding all these things, understanding how to integrate all these tests into the pipeline. Okay, we as a QA, we understand about API, we understand about system tests, we understand about test case, test plan, bugs, obviously, but we need to understand also how it's working a pipeline, how we can integrate our automated test cases in that pipeline. Okay, and this is also a good advance because we are learning new things. So the role of QA is evolving to a new stage where we can learn new skills, we can use new tools, and we can collaborate more with different team members. That way also we can get faster time to market, better quality products, and better customer experience at the end. We need to care also about different things that with manual tests we don't think about. Automated testing, also parallel testing. So we need to think that having a lot of tests, you have seen unit, API, system, performance, security. We cannot run them only one by one. We should think on parallelizing somehow all these test cases. We need to think also on testing the scalability of our platform. And we need to think on testing the building of our application also, via smoke testing or whatever. Okay, talking a bit about parallelization, it is also important to know about virtualization, containers, virtual machine, so on. So it's not so difficult. So, okay, Docker, it is something that people outside DevOps, they are scaring a lot about Docker or containers or whatever, but it's not that difficult. So, for example, in this Docker compose file, you can define different machines with different configurations, Firefox, Chrome, different browsers, and you can parallelize your tests this way. So we need to learn also about this. Also, we need to learn about integrations. So we need to understand that our traditional testing, for example, using a manual test cases application, is not outside of this process. We can integrate this kind of tools with our pipelines. We can pass the results of the automated test cases to the manual test cases tool. And we need to integrate all of this. More testing, more things that we need to test. We need to test at the beginning and we need to test at the end. This is called shifting left and shifting right, the testing. Talking about left shifting, if we go to the beginning, we need to do some discovery, some planning, some understanding of our application. Discovering maybe is a task for product managers, talking with the customer, deciding what they want. Planning is, we should be involved in planning because we need to test based on risk. We need to know which are the changes, which part of the application is going to be modified, which dependencies we have. So we need to determine which kind of test we are performing. And finally, we need to understand. So everyone should be aligned in the team with the behavior of the application. So we need to understand the stories, the requirements. So we need to do TDD and BDD, as I said before. Okay, this is an example of risk-based testing and a conversation of BDD because we have some advantage using risk-based testing, for example. So even if you are doing automation testing, maybe sometimes it is not necessary to run all your regression tests. Maybe, okay, they are automated, but they can take 2 hours, 3 hours, 1 day. But maybe if you are not modifying your whole application, why are you running all your test cases? Just tag them by functionality or by component and just run the test cases that have been modified. When using BDD, we are getting a common understanding of our application. Conversations are happening. So most of the problems in software development are due to the communication between the teams. So doing BDD is a way to remove this problem. Okay, when talking about right shift, we are moving to the end of the process. The end of the process, obviously, is releasing to production. Traditionally, we didn't test anything in production, but we need also to test in production. How can we do that? we can use some techniques like blue-green releases or canary releases. Basically, the difference between them it is that for blue-green deployments, you have two different environments, one with the old version of your application and another one with the new version. So you can route all your users still to the previous version that you know it is working, and you can have in production the new version, but no customer are using it, so you can test there. You can run tests in this performance test even. You can run your test here. And when everything is okay, you can route your users to the new version. Canary is quite similar, but instead of switching the 100% of users, you are just having, again, two environments, but you have a percentage of users still using your old version and a small percentage using the new version. So you are passing a user from one to another, and you can see if anything is broken or anything is failing. Okay, so we can perform testing also in production. And also we should care about monitoring. So QA testing is also about monitoring. We need to see the usage, that the metrics, how the user are using the application, what is happening. So we need to do that. This way we can think on how to improve our system or how to perform new features. Okay. Okay, so basically this is going to derive. This is taking a path in the future. This probably is going to be called holistic testing, where you can see in this infinite loop, in every part, we can do a lot of testing. This is continuous testing. So in plan, we can identify risk. In this cover phase, we can test ideas. In deployment, we can test the deployment process. In release, we can test in production, as we said. Test automation, how monitoring your customer, and so on. Okay, let's see some examples. So let's see how this, because we have seen a lot of testing types, and probably you say, okay, but I need to know how to integrate this in a real pipeline. So let's see in an application. Okay. First of all, let's take our first contact with a pipeline. I have put the code in the latest post in my LinkedIn, so just in case you have your laptop and you want to try it. Okay, but this is the code for a pipeline. Let's try to understand. First how it is working. Okay, so this is GitLab CI/CD. It's a tool. It's an application for defining pipelines. Basically, you are defining the pipeline in a file in your code, your GitLab CI YAML file. You can define your pipeline, and it is not so difficult. So for the person that QAs that they want to see, they don't want to see any related to DevOps, you can see here that it is not so difficult. So for example, in this pipeline, we have no code, we have no application. We can define a pipeline even with no code. So this is a pipeline. This pipeline has two phases. So we have seen the diagram, a lot of phases, deployments, environments, whatever. But this is an easy one. Only building and testing. That's it. So for example, at the beginning, we just define the phases, the stages that our pipeline is going to have. Just building and testing. Later on, we define these pieces, these blocks of code for every phase. Building, okay, just our script is making a new directory, a new folder, and creating a TXT file inside that folder. That's it. That is the building of our application. We have no code, so we are creating an application that it is a file in a folder. And we are storing this artifact in the build root, okay? Second phase, testing. Because we don't have any other application, we are going to test that the file is created inside that folder. That's all. We are just checking that the file has been created. That's it. Okay, so this is kind of ironic because updating this file updating the code of my project, the pipeline is also code. So updating the code is going to launch the pipeline. It's going to trigger the pipeline. So I'm updating my pipeline, and this is going to trigger the pipeline. Okay, so I just commit my change, and the pipelines should be running. Okay, this is demo problems. Ah, no, it's running. Okay. Okay, so it's running. You can see here, it is running. First stage, we can check it. It's passed the first stage. Okay, the file, the folder and the file have been created. We can check it even here. Job artifact, you can check, you can browse. Here is it, our folder with our file. Okay, so it is created. Let's check the second phase. Testing, also passed. Okay, let's see another pipeline with more stages. Okay, so let's check this. We have 3 stages here, 3 phases. So it's related to testing. It is doing a lint on all the CSS file, and it is doing a lint on the JavaScript files, and it's running the unit test. Again, it's so easy. Just define your phases and put the scripts, the proper commands to run, to perform the action that you want. So for the lint CSS stage, and just running the lint CSS. Same for the lint JS and for the unit test, and just running with the test command under this folder, that the unit test should be there. Okay, so we can run this from the CI/CD section. We can run the pipeline also manually. And it is running. Okay, it's in the first stage, and it is running. We can see also the previous run. So, for example, this is failed, this is passed. Let's see, for example, for this, the unit test. You can see here the unit test, only 4 unit tests, and they are passing. Okay, so it's not so complicated. What about performance? Sorry, not performance, API. Okay, as I said, you can use Postman. Just create a collection, create all your requests, create your test, and you can create a pipeline only with a phase or more phases, deployment, whatever, and you can include the execution of this collection. You can use Newman to run Postman collection, and the script is saying that I'm running my collection.js. The collection.js is under this project, of course. And also, it is even reporting the results in an HTML file, okay? We can see some execution for this pipeline. We can check, this is passing. You can check here the result of the execution, but also on the artifacts, you can get your report. So report HTML. Okay, here you are. So it's as easy as getting your collection, putting on the repository, and including this script on your pipeline. Okay, one more. I think this is the last one. No, not the last one, but almost. Okay, for example, this pipeline is a bit more complicated. It's building a front-end application, deploying into an environment, and testing. Okay, some variables we can define. Don't worry if you don't know how to define that. You need to know only how to include your automated test cases in your pipeline. This is all the building stage. This is more complicated, but it is building. Probably the DevOps role is doing that. This is the deployment phase with the script. And let's move to the final phase, the testing. It is for Cypress test. Basically, it is using a Docker image, it's installing Cypress, and running your Cypress test. So you need to understand the phases, you need to understand where to include your automated test cases, and that's all. It's not so difficult. You can do it with GitLab CI. You can do it also with GitHub Actions. It's quite similar. It's quite similar. For example, on this pipeline, we are doing testing and building. We have here the job for testing, the testing phase, and we have here the deployment phase. If the tests are passing, we are moving to the deployment. Okay. Okay, so this was a quick demo, just for you to lose your, for you to not scare about GitLab or about DevOps. And here you are some resources that I have used for this. Again, these are my contact details. And that's it. Thank you all. Please read this file.
Okay.
If any question now?
Yeah. Any questions for Fran?
Hi. Sorry, probably you haven't tried it, but there's the new framework that is really similar to Cypress. It's called Playwright. I believe it's from Microsoft. Have you tried it?
No, never try. I know the tool, but never try. But I think you can integrate in a pipeline the same way.
Yeah, I know, but just if you have any experience, if we can connect.
No, that tool, I have not used it, but should be quite similar.
Do you have any big data CI/CD testing tips?
Not really, to be honest.
Okay.
When you say big data, so probably it's another kind of testing, different from the type that we have been seeing here. So probably you need to think on big amounts of data and so on. So it is more focused on preparing your data, maybe. So this preparation of the data should be also take part of the pipeline. So if you need to prepare a new environment with a new database or whatever, you need to care of creating all this stuff, all these scripts before you are running your test. And all this process should be automated and being part of the pipeline as much as you can.
More questions? Fran, before we close off? No. Okay, I think that's it. That's it then.
Okay.
Big applause.
Thank you.